Hi, and a good day to all of you. The third lecture is still on the diversity of mammals, so this is the second part. If we take a look at the trends in mammalian diversity, so what do you see there? Mammalian diversity, as you can see, is highest in the tropics, at least twice those in temperate regions of similar land area. Early studies have shown that mammalian diversity is influenced by elevation. For small non-volant mammals, diversity is up to the transition from montane to mossy forest or at intermediate elevations. However, habitat disturbance affects distribution and diversity, especially of small non-volant mammals, since there are species that are sensitive to and species that are tolerant of habitat disturbances. Thus, structural complexities of intact habitats positively affect diversity. Our study in Mount Makiling showed that there are differences in stratification seen in bats, wherein insectivorous bats decreased the higher the forest strata, while frugivorous bats increased the higher the forest strata. For non-volant mammals, which were generally omnivorous, habitat use was restricted to the subcanopy to canopy layers. Mammalian diversity and biodiversity in general is threatened with species population declines that lead to extinction. Extinction is the process whereby groups of organisms die out. As biologists, I guess you'll agree with me that extinction is a natural process. But how about mass extinctions? Mass extinctions are periodic rises in the extinction rate above the background or normal level. The rapid loss of species we are seeing today is estimated, according to IUCN, to be between 1,000 and 10,000 times higher than the background or expected natural extinction rate. And this is a highly conservative estimate. Unlike the mass extinction events of geological history, the current extinction phenomenon is one for which a single species, ours, appears to be solely responsible. This is often referred to as the sixth mass extinction crisis, after the 5 known extinction waves in geological history. How sad. In a recent study by Anderman et al. In 2020, they found out that on a global level, current extinction rates are around 1,700 times higher than those at the beginning of the late Pleistocene, as shown in the figure. The black line shows the declining diversity, and the red line the magnitude of extinction rate increase relative to the starting rate through time. They also found essentially no evidence for climate-driven extinctions during the past 126,000 years. Instead, human impact explains 96% of all mammal extinctions during that time. The last living individual of the world's largest marsupial carnivore, the thylacine, also known as the Tasmanian tiger due to the distinctive stripes on its back, died in 1936, and the species was proclaimed extinct in 1982. The establishment of the first colonies in Tasmania in the early 1800s also brought the farming industry, and settlers cultivated livestock such as sheep and cattle. Despite evidence that feral dogs and widespread mismanagement were responsible for the majority of losses, the thylacine became an easy scapegoat and was hated and feared by the Tasmanian public. As early as 1830, bounty systems for the thylacine was established. It is estimated that at least 3,500 thylacines were killed through human hunting between 1830 and the 1920s. The thylacine population in Tasmania at the time of European settlement was estimated at about 5,000 only. A video of the last living thylacine may be seen using this YouTube link. We may have lost some species, but new mammal species still continue to be discovered. Or more appropriately, species new to science continue to be described for the following reasons: interest in biodiversity, growing concern for biodiversity conservation, scientific explorations, new technology, or purely by accident. Note, however, that patterns of discovery are influenced by many factors, including geopolitical considerations. For example, discovery of the many new species described from Vietnam and Laos is linked to the opening of these regions to scientific exploration after years of being closed off. Many new, sometimes cryptic species have been discovered in older museum collections, as well as in the field, reiterating the importance of museums in the long-term preservation and maintenance of voucher specimens. It is also suggested that the great majority of new mammal species are restricted to threatened areas of high endemism and are therefore conservation priorities. New mammal discoveries also tend to be small mammals and those with limited geographic range. One of the recently described fruit bats in the Philippines are the Desmalopex microleucopterus by Esselstein, Garcia, Saulog, and Heaney in 2008, and Styloctinium mindorensis by Esselstein in 2007. This is the Mindoro stripe-faced fruit bat. Seven species, all of which are members of the genus Apomys, forest mice, were published on May 20, 2011 in Phildiana by Heaney et al. 2011. These were Apomys aurorae, Apomys banahaw, Apomys brownorum, Apomys magnus, Apomys minganensis, Apomys sierrae, and Apomys zambalensis. And this, as you can see, have different distributions. Aside from the body measurements and cranial characteristics, these species were genetically distinct from one another. In 2009, Musiromys gulantang was discovered in Mount Banahaw. This was found to be closely related to cloud rats. And in 2014, 3 other species of Musiromys were discovered in Mountain Province, Benguet, and Aurora. This shows you how the measured characters were used and analyzed using the principal components analysis. Principal components 1 and 2 clearly explain the distinction between the 4 species. Aside from mammals that are new to science, we also have rediscoveries. For example, the Psonia chapmani, the Visayan barebacked fruit bat, was thought to be extinct in the 1970s. In 2001, it was rediscovered in Cebu. And in 2003, more individuals were recorded in Negros. At present, it is still categorized as critically endangered. The Cebu Tamarao, Bubulus cebuensis, is a fossil dwarf buffalo discovered in the Philippines and first described in 2006. The most distinctive feature of Bubulus cebuensis was its small size. Large contemporary domestic water buffalo stand 2 meters or roughly 6 feet at the shoulder. And it was even smaller than our extant Tamarao, Bubulus mindorensis. According to Ceballos and Ehrlich 2008, new mammal species may be categorized into 3 types of discoveries: morphologically distinct species, cryptic species that may be morphologically similar to others but have been found to be genetically distinct, and subspecies that have been elevated to the species level. But the question is, what are the implications of having these species that are new to science? What would this contribute aside from another scientific name to memorize, another number added to the species richness, or perhaps another species to go extinct? Would it have been better if they were left undiscovered, hidden from the prying minds of scientists? What is so exciting about discovering new species? So that's something for you to think about. For your learning activity, you are going to search for a new mammal species that was described from 2018 to the present. So you will submit a 1-page report in doc format, Microsoft Doc format, okay, not PDF. And this is the suggested format of your report. So the new species, the scientific name, including the authors and year of publication, common name and local name, if any, distribution, where the holotype is deposited, how the species was discovered, the type of discovery. Is it a morphologically distinct species, a cryptic species, or a subspecies that was elevated as a species? And then your explanation. Description of the new species. You may include a photo, threats to the new species, if there are any, and comments, your comments on the paper and on the new species, and then of course your references. Okay, so that's all. You may proceed with your learning activity. Have a good day.